Good morning, pre-calc. So now we're going to be moving on to pretty much a new subject for you guys, and these are called matrices. And hopefully we'll get to the point where you'll see how these are actually kind of intertwined with systems of equations. We can actually use them to solve a little bit quicker and easier than what we were doing last week. So we're going to start off by just checking out the definition of a matrix. It looks like this right here. That's an example of a 2 by 3 matrix. Okay? And the definition for it is just a rectangular array of variables or constants in rows and columns. Okay. Sorry, little end there. And it's usually going to be enclosed in brackets like that example we have right there is. Okay, so let's do some quick vocabulary here. So the elements of a matrix are going to be the individual values within it. So for example, all these numbers right here, those are all elements of that matrix. So the way we denote any given element is like this. Say we have a matrix A, we would say AXY is used to denote each element, where X is going to be the row number and Y is going to be our column number. Okay, so let's take a look at this matrix right here and just make sure that we understand how to find a given element. Okay, so a little side note here, matrices are going to be named using a capital letter. So this is matrix A right here. Okay, and if we were trying to find A25, okay, that just means go to our row 2 and column 5. So A25 is row 2. We have 1, 2, 3 rows and 5 columns. So row 2, column 5. That would be -2. And let's go ahead and try number 2. That's row 3, column 1. So row 3, column 1, that's going to be 5. And so go ahead and take a sec, try numbers 3, 4, 5, and 6. Pause the video if you'd like. And I'm just going to continue on. So unpause it when you're ready. So 1, 2 is going to be 40. Okay. 3, 4 is going to be 52. 1, 5 is 21, and 22 is going to be 2, 2, that's 32. Okay, so make sure that you got that correct. Okay, so now let's take a look at the dimensions of a matrix. You might have noticed that this matrix had 6 elements. It was 2 by 3, and this guy was 3 by 5. So we can have different sizes of matrices. Okay, so the way that we denote the dimensions of a matrix are by just listing out its number of rows and number of columns. So a matrix with m rows and n columns is called an m by n matrix. Okay. So an m by n matrix, so the number of rows and the number of columns. So let's go ahead and make sure that we understand how we could tell the dimensions of a matrix. So this guy has 1 row and 3 columns, so this would be a 1 by 3 matrix. This one right here has 4 rows and 2 columns, so that would be a 4 by 2. This guy's a 3 by 4, and this guy's a 2 by 1, 2, 3, 4, 5, 6, a 2 by 6. Okay, so next up, another definition, equal matrices. So 2 matrices are considered equal when each element in one matrix corresponds with each element in the other. Sorry, I got a little further than I wanted to there. Right. So now let's finally, before we start some operations, look at some special matrices. So first off, we have a row matrix, and that's just where we have a single row in our matrix. We also have a column matrix, which we just have a single column. So that would look something like this. We have a square matrix, and that's when we have the same number of rows and columns. Here's an example of a square matrix. And a zero matrix is when every single element of the matrix is 0. So now let's jump over and do a little work on addition, subtraction, and what we call scalar multiplication. Right? So addition and subtraction is pretty easy when it comes to matrices. The one thing that you have to be sure of is that matrices can only be added or subtracted if and only if they have the same dimensions. So you have to be dealing with the same sized matrices in order to actually add them. But if they are the same size, all you do is just add or subtract their corresponding elements. So for example, here I have x plus y. So here's x, here's y. First off, do a quick check and make sure they have the same dimensions. These guys do. And then all we do to get our answer is do 24 plus negative 15. Okay, that's going to give us 9. And then we do negative 8 plus 29 is 21. Negative 3 and 17 is 14. Negative 4 and 9 is 5. 6 and negative 5 is 1. And negative 17, negative 2 is negative 19. And there is x plus y. Right? With subtraction, just make sure that you are subtracting each element. Sometimes it's hard to remember what that ends up looking like. For z minus w, first off, looks like these guys have the same dimensions, so that's good. And let's go ahead and do these guys. So it's going to be z minus w, so I'm going to do negative 3 minus negative 1. Remember, that's like adding a 1 because we're subtracting a negative, so that's going to be negative 2. And then continue on, I get negative 11, negative 16 minus... It's going to be negative 5. Didn't really give myself enough room. I'm going to extend that a little bit. And we got 0 minus 15 is negative 15. 12 minus 8 is going to be 4. And 9 minus negative 20 will be 29. Right, so we should get something like that. And then sometimes you'll encounter situations where it's just not possible to add or subtract, because remember we said we can only add or subtract if our dimensions are the same. So w plus x, check it out, this is a 3 by 2, this is a 2 by 3. So the dimensions are not the same there, so we were just right that this is not possible. All right, so go ahead and try this last one, number 14. So pause the video and take a shot at it, and unpause it when you're ready, and you can see our answer here. So we're doing x minus y, dimensions are the same, so we're set, and we are subtracting, so 24 minus negative 15, that's going to be 39. Negative 8 minus 29 is going to be negative 37. We got negative 3 minus 17, negative 20. Negative 4 minus 9. And you should get something like that for your answer. Okay, and then finally our last deal that we're going to check out today is scalar multiplication. So matrices can be multiplied by a constant, and we call that constant a scalar. Okay? In this process, we call it scalar multiplication. All we have to do is multiply each element in our matrix by that scalar. Okay? So for example, if, and we're using the same matrices that we have up here, if we have 3x, we're just going to take our matrix x and we're going to multiply everything by 3. So we're going to have a matrix of the same dimensions. It's going to be 24 times 3 is 72. And then negative 8 times 3 is negative 24. And I just continue to multiply everything by 3. So you get something like this right here as our answer. This guy could end up being a fraction, like 3/4. So 3/4 w, we just multiply all of those numbers in w by 3/4. So we're going to have negative 3/4. That's 3/4 times negative 1. right? We got negative 33 over 4. That was negative 3/4 times negative 11. We got 3/4 times 8. That's going to be 24 over 4, which will actually reduce this to 6. And then continue on, we get 27 over 4 here. And we get 45 over 4. And negative 20 over 4, I think that's going to be negative 15. Right? We get something like that. And then we can even take it to another level where we are doing both scalar multiplication and addition and subtraction together. So make sure that you use your order of operations in this scenario. Sometimes you'll see, like in 17, we're going to do our multiplying first, but on 19 we have to do the w plus z first because of the parentheses there. So for this guy, I'm going to do negative 5x. So that's going to be taking my x and multiplying everything by negative 5. So I'm going to get something like negative 120. I am just doing 24 times negative 5. I'm going to have 40, 15, 20, negative 30, and 85. Now I'm going to add 2y. So I got to multiply everything in y by 2. That's going to be negative 30, 58, 34, 18, negative 10, and negative 4. And then now I'm going to actually add them together. Now remember, because these guys have the same dimensions, that's definitely possible. So my final result is going to be negative 120 plus negative 30, negative 150. And we'll continue on. We get 90, 49, 38, negative 40, and 81. Okay, so I'm going to leave it at that for now. Just remember, for these guys, you would actually have to do the w plus z first, and then multiply your answer by negative 3. It's just because we're doing order operations just like we've done in the past. So for homework, let's go ahead and have you guys just let's just do the odds on homework 4. All right? Hope you guys have a good day. I'll see you.